Welcome, it's a great day to be a miner. In today's video, we're going to do some in-depth testing on this guy. We're going to overclock it. We're going to do some different heat testing. We are going to apply a bunch of different overclocks and check the different powers, the efficiencies, different orientations, and we're going to tell you whether or not you should overclock this, and if so, how you should go about it. So before we do that, let's go ahead and spin that intro. Alright, so here we are again, and this is the IceRiver Ks0 Ultra. This guy is stock, supposed to do 400 gigahash on about 100 watts at the wall, and of course there is a plus minus variance of 5% on these things and pretty much on all ASICs, and that kind of varies based on the silicon lottery, how good your chips are. You could have same chips cut from the same wafer that actually perform much differently, so there is some chip variation, but for the most part this should do around 400 gigahash on 100 watts stock with no additional upgrades, no opening it up, not adding heat sinks, not adding fan on the side, adding heat shroud. But we are going to use Tswift Software, and we are going to test this thing in depth. We are going to first, we're going to test it laying down. We're going to test it like this, vertical orientation with no fan. Then we're going to strap a fan on the side. We're going to do just a USB fan, but we're going to leave the sides on. That way we haven't voided the warranty yet. And then we're going to check the numbers. We're going to see how well it's performing stock, because these actually are notorious for you have to heat them up. You have to get the chips in around the 70s, 70 Celsius to get those chips really hashing the way they should be. If you super cool this, it really won't even hash to what it's advertised. If I were to open both sides up and put a fan on the side, it's going to bring those chips down to the 30s, and this thing's going to hash at like 250 gigahash. So that being said, let's go ahead and get some of the testing done. And I think what we're going to do is we're going to time warp, and we're going to talk about everything we did, and we'll go over all of our nerdy numbers, and we'll put a nice little spreadsheet and tell you exactly how to do the overclocking, what it entails, whether or not you should overclock, and then we'll do a full assessment and we'll close this thing out. Before we do that, of course, the disclaimer, yada, 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 you overclock at your own risk. If you brick it, that's on you. No, we're not responsible, neither is Tswift, as stated in their software file. So yeah, let's go ahead and do a magic time warp into the future, and let's get some of these nerdy numbers. Ready, set, go. Hey, Futured Altered here with an altered future. So first and foremost, before we go into all the numbers, we've already got all of our testing done. It's been an entire day, but before we actually dig into the numbers and how well the overclocking went, let's first go over to where to get the software and the two things that you need to download. First and foremost, you should download the IceRiver monitoring tool from Tswift, from his Telegram, which I'll put links down in the description for these so that you can quickly just download the monitor and the actual firmware. From his Telegram, they have all that listed on there. He also sells different ASICs. They also have a few different variants of overclocking firmware. So first and foremost, we're going to download the latest version of the IceRiver monitor tool. If you have an older version, it's not going to work because it's not going to pull in the new Ultra, and of course you need to have the newest model to bring that in. So it's going to be, let's go ahead and just, we clicked here, we downloaded the link, we extracted the file. All the files, we extracted it, we unzipped it, and then we just ran it. It's an exe. Okay, and here's what it looks like. So you're going to put in, once you've already set up your device, you're going to go and get the IP address that you're using for your specific Ks0 Ultra. You're going to select the Ultra from the bottom of the list. You're going to pop that in there, and then you're going to hit read. And it's going to read all of your chip temperatures, all 12 of them. There's 12 individual little chips in there. And then, of course, it's going to give your chip temp min and your maximum. And then it's going to give you an average across all of your chips. It's going to tell you the 5-minute hash rate, your 30-minute hash rate. It'll tell you what version of your firmware, your fan speeds, and then your runtime. And then over to the right, it'll tell you your pool, actually all 3 pools that you have plugged into the software. So this thing is gold for overclocking specifically, because you can actually monitor the temps of your chips and make sure that you're not trying to fry your temps, and make sure that you're kind of in that sweet spot here. These are actually a little low, running down in the 40s. It really needs to be running up around in the 70s. Okay, so that's better. That was an old version we were looking at. So as you can see, my temps are right in around the 70s, and that's more of your target, your sweet spot. You probably want them up around above 65, in between 65 and 75 on your temp, to achieve your target hash rate. And as you can see, my average hash rate in the last 30 minutes is 423 gigahash, and that's been running for... And then, of course, that's been running for a while, and that's a pretty accurate reading. And then it also gives your temps for your chip min, your max, your average, your chip voltages, which is not reading right now, which is kind of weird over to the right. But you got your board temperature, your 5-minute hash rate, 30-minute hash rate, the firmware version, and then over on to the right side, which is covered up with my picture, is just your different pools you're using that you have plugged in, your pool and your wallet address that you've already plugged into the miner itself. So yeah, this thing is crucial. It's clutch for overclocking to make sure that your temps are safely in that good range. So there's number one. You need to get the overclocking, the IceRiver monitor from Tswift. And even if you're not overclocking and you just want to monitor your hardware, this tool is gold. This thing is great. So there's that. And then, of course, it's not just for the Ultra, it's for all the IceRiver different models there. So we're going to close that out. And then the next thing, of course, you need to go and download the different files for the Ultra, the different firmwares. Tswift, the way their firmware works is they have already pre-programmed in frequencies and voltages. And then when you apply the firmware, it's applying that frequency and that voltage to up your clocks, essentially. When you're overclocking an ASIC, just like you're overclocking a CPU or a GPU, you're turning up the clocks higher than stock, and so that it performs better. And as you turn up those clocks, you have to feed it more voltage to make it work properly. So again, we're going to go download the firmware. And so yeah, here is the file. We go to his Google Drive, we download this, we extract it, and then... Okay, and now here are all the files included in that one zip. Of course, you have your initial _update file. So first and foremost, before you do anything, there is a README text in here, and that README will go in depth on how you do this process. And it also, of course, gives a disclaimer that, hey, you don't want to overheat this thing, you don't want to fry it. If you're using certain files, you need to do certain mods first. The different power supplies that you need to have when using the different files. For instance, if you're using a stock KSO, you're getting a stock power supply. It supplies 100 watts because that's what this power is needed. So it's, I believe, 120 watt power supply. Well, obviously, if you're trying to overclock to 150 watts, that's not going to work. That's going to fry that power supply, and it's not even going to get the full draw. So you have to buy an upgraded power supply. There are different levels of power supply. You can get a 150 pretty easily, pretty cheaply, 180. That's what I mostly run. You can get 230 watt, and then if you're going for crazy overclocks, you can get like the 300. For our testing today, I have decided we're only testing stock. I'm not going to open this thing up, and then we're going to get the data just by running the 505 gigahash file, all 3 variants, and we're going to run all 3 variants of the 562 gigahash file. Those requirements for that state that, so the 505 is a 150 watt power supply, the 562 170 watt, the 618 is where you jump clear up to 200. So I'm going to focus on the 505, the 562. So for this testing, we're using a 180 watt power supply. Again, I'll put links down in the description for some different variants, both the 180 and the 230 power supplies, in case you are interested in either. So first and foremost, make sure you read down through all of these warnings. There are some really good information in here. Read this file, this README completely. It's giving you warning. It says, do not, number one rule, do not under any circumstance reset to factory settings after overclocking, either by using the reset button on the machine, holding it for 30 seconds. Don't do that once you apply the Tswift software, or by using the reset in the web interface, the GUI for the for IceRiver. If you do either of that, you could possibly brick this. You've been warned. That's the most important part. If you apply the Tswift software, there is a specific way to flash back to factory, and I have tested it and it does work. So we'll go over that last. So then the next part is, after you flash the initial firmware, then you have to use the Tswift software. You can't backtrack out until you do the official Tswift factory reset way. That's the first and foremost. So now, it's also telling you, if you're going to use any of these higher hash rate ones, you're going to use the 618. My opinion, if you use right here on the right, it does say that if you're using a 505, they want a high performance fan blowing air through the machine. You're using a 562 file, again, just a fan on the side, and they're saying a high powered fan, not just the USB. I tested with the USB and it worked fine. My ambient temperature is not that hot here in that specific area. They are saying to use a DC style fan, and in my opinion, as long as you're doing the 505 and the 562, you can get away with a USB only fan strapped on the side. Now, whenever you go up to the 618, it's saying the high performance fan with the nice fan shroud, which I'll show you those in a little while, and they want you to put the copper heat sinks on the MOSFETs. These actually disassemble exactly the same as a K0 Pro. I have in-depth video on how to disassemble those, how to repaste them, how to repad, and how to add the MOSFET. Exactly the same process, same amount of chips, same layout, same everything for the Ultra. So make sure to check that video out if you decide to go above the 562 file. You want to go with the 618 or the 676, that's what you need to do. You need to get those MOSFETs cooled. Those MOSFETs are part of the power delivery system, and if they don't stay cool enough with the copper heat sinks, it will overheat, it will shut down, you'll have all kinds of issues. You could even damage the machine. Mostly it will protect itself and shut down, but you have been warned on that piece. Now, we've already went through the instructions, yada yada yada. Now, we have our files here, and the very first thing you need to do before you do anything, if you have the monitor tool open, you have to close it. You can't have the monitor tool reading. If you have the monitor tool reading and you try to apply the firmware, it'll stop you. It won't let you apply that firmware. First and foremost, turn that off. Close it. Now, next, you have to start with, if you've never changed to Tswift, you have to start with this init initial underscore update.bgz firmware. So from your dashboard, you'll go and upgrade the firmware. From your dashboard here, you're going to go in, you're going to hit firmware tab, firmware upgrade tab, you're going to hit select file. You're going to go to your folder that you just downloaded that. You're going to find this init slash update underscore update.bgz. You're going to select it. You're going to hit update. You're going to let it update. It's going to say successful. Do you want to restart? Yes, restart the machine. Then, once it gets up and running well and it's actually starting to hash away and you're seeing some action there, go back to firmware update, and then you're going to actually apply one of the update files. There are 3 files for each level. So you've got 505G, 505GH, 505GL. Start with the lowest file, and then you're going to work your way up. And the L stands for low hash rate, so that's the one you want to start with. The G is the normal. The GH, H for high power. That's only going to be used if you've really lost the silicon lottery and it's not working. So the first thing you do is use the low power, apply it. If it starts hashing away and after a half hour or so, it's still hashing and it's getting the proper hash rate, no rejected shares, you're golden. That means it's working, you're fine. If you are having problems with the hash rate dipping way down, rejected shares, try the G file. The G file is using a slight bit more power, so Instead of 150, or you may be using 155, 160. Then for the H, you're going to use, again, another 5 or 10 watts on top. So you really want to try to get that low power one in there and working. And if you did, then you're great. If you're not, So you start with the 505. If you get good results with the 505 and you're happy with it, you can move up to the 562. Again, start with the low hash rate, the regular, and then the high power if those first two options don't work. Then again, if you're going to go up to the 618, you got to do some modifications. You got to open it up. You got to put some heat sinks on those MOSFETs. You got to, I would highly recommend repasting, putting a shroud on there with the fan blowing directly in through the front and blowing out the back. So that's something too. And then if you're going extreme overclocking, peace be with you. But yeah, you need to do some mods. You need to make sure these things are cooled or they're not going to run properly. If you want to see what happens when you start really overclocking them, Mad Electron Engineering, Rick, he did a good video. Go check it out. He's dabbling. He's trying to get as much as he can. Keep an eye out. He'll be dropping some new ones, I'm sure, on that as well. So yeah. Enough droning on. That's how you apply the firmware. So yeah, if you are successful, you'll get the nice Tswift logo over on the side. It'll say Tswift, and it's got the nice model picture of. That's actually really Tswift, by the way. It really is Tswift. Anyway, you'll get the nice picture of Tswift on the side of the dashboard, right on the left. And then you'll see your hash rate going up. You want to monitor it both at the pool and, of course, in the firmware itself. So that's the process of going into the overclocking. Of course, we've already done it. We've done the full testing. So let's go ahead and jump to the numbers, and then we'll see how our testing went. All right, so here we are. These are the nerdy numbers. So how did we test? We started with just stock, and we actually just started vertical with the Ks0 because it's been proven time and time again, you need to run them vertical to get the best cooling. Running them on the sides either way is not optimal. You're not getting enough airflow pulling up through. Turn it sideways, you're going to get more cooling because more surface area is exposed to the ambient air. So first and foremost, we tested with stock vertical. We added a fan on the side, blowing in stock vertical, because blowing out just does not cool it very well. That's been tested quite in depth as well. Then we left the fan on for the rest of the time. We upgraded to the 505 low power, the 505 regular G file, and then the high power, then the 562 low power, and then the 562 regular file. And we went ahead and we let each one run for at least 1 hour. We recorded the power, the 30-minute hash rate on the dashboard, the 1 hour hash rate at the actual pool, the temp 1, temp 2 in the software, the fan RPMs, the chip temp average from the monitor software, and then we calculated the efficiency as for the hash rate versus the power used. So for instance, the first one we did a 1 hour pool, 426 gigahash at the pool on 100 watts, and then we calculated that to get a 4.2652 efficiency. So let's zoom in a little closer here. Okay, so our stock numbers, as you can see here, 100 watts, we went up to 108 by just adding a fan on the side. That's a USB powered up here RGB fan. We'll make sure to put a link down in the description for that. We then went up to 150 watts when we went up to the 505 gigahash low power. We went with the regular 505G file, not the high power, and it went up to 158, so it went up 8 watts. Then we went up to the 505 high power, and it jumped another 9 watts. So 17 watts between the low power and the high power on the 505. Next, we used the 562 low power and then the 562 regular power, and we did 175 watts and then 190 watts. So it is actually kind of scaling in a normal increasing manner as we go. As we move up the file chain. Now I'm only using 180 watt power supply, so the fact that we got it clear up to 190 on the regular 562 is telling me that you should not run the 562 unless you're going to upgrade to the 230 watt power supply. Again, I'll put really good options for the 230 and the 180 down in the description. But yeah, we went ahead and ran it for an hour, and I was a little nervous because that thing was really scorching hot, but it made it for an hour and it's still working. So the biggest takeaway, there's a couple. The first takeaway is that the ASIC itself hashes better when it's in that sweet spot of the temperature between 65C and 75C on the chip temps. That's a huge takeaway. So you can't run it super cold. You're not going to get full hash rate. You run it too hot, then you could really mess up the hardware. So there is that sweet spot. In my opinion, it's between 65 and 75, probably more like 65 to 80 even. The fans tend to not even want to kick on until it's almost at 85C. So by stock without actually adjusting them yourselves. So the second biggest takeaway is the efficiency. The efficiency continues to drop dramatically as you increase and go up the chain on the more hash rate. So the more hash rate is using more power, but as you're adding more power, your hash rate's not going up as much. So you're kind of increasing that power and not getting that hash rate to go up as much. So my best efficiency testing was to run it stock. To run it stock, completely stock, even without the fan on the side, was actually my best testing. So like right there, 4.265. Then we used the fan on the side, and we did pretty good as well. The extra 8 watts actually by using the fan cost us a little bit of efficiency, and it's still really great efficiency though, at 4.02. Then we went up to the 505, jumped clear up to 150 watts, and it dropped dramatically on our efficiency, 3.32. Then we went up to the middle file on the 505, 3.07. It's not very good. The 505 high power, 3.14. Then we went up clear up to the 562 file. We went to 3.13. Then up to the 562 regular, 2.9. So it's getting worse in efficiency as you go up. Now, we only tested up through the 562 regular, but Tswift gives us some model numbers of what it should look like if you're going up to the even higher. If you're going up to the 615, you're using 200 watts. You go up to the 676, you're using 235. You go up to the 700, you're using 280. And that's only if, number one, you can get it to run properly. Number two, if the low power file is working, because the 200's at the low power. The regular's probably more like 210, 215. Probably more like 210 for the regular on this one. So then your efficiency is definitely dropping more. 3.09, 2.87, 2.5. Yeah, so there, if you want to take a screenshot of it, there are my results, my nerdy numbers. So that about covers the testing. Let's go and talk about whether or not you should OC this thing. Let's go. If you want to get that extra hash rate, 100%, I would recommend go buy a whole nother unit for $239. Buy your own power supply, power that thing up. You add another $30 on there. Over time, that unit will way outproduce the extra that you're using the juice on the wasted efficiency by overclocking compared to just buying a whole nother unit and then cranking it up. That's just my opinion. It's my 2 cents. Of course, if you are going to overclock, I highly recommend just using the 505 or the 562 file, leaving the side casings on, putting a fan on the side, blowing in, trying to get as much air on those chips as possible. And not actually voiding the warranty and opening it up. It will stay cool enough and it will keep those chips in the ultimate tip range as long as you're not putting it in a 100-degree shed. So, but tell me what your thoughts are below. Should you bother with overclocking? Did you overclock? Did you waste your time doing this? Is it worth it in your opinion to get that little bit extra hash rate, put the extra stress on the machine, and really kind of crush that efficiency that this thing is known for? Tell me your opinion. Tell me down below in the comments. Tell us all. Tell me I'm wrong if I'm wrong, because I love it. I love a good argument. Tell me I'm wrong. but give me some good points as to why. I think that about wraps it up. If you're new to mining, need some help, make sure to join the Misfit Mining Discord. Always plenty of seasoned vets in there willing to help you out. And if you like the video, you know what to do. Smash that like button and subscribe for future content. Thanks for coming along and enjoy the ride.